Hello, 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 everybody, and welcome back. We're looking at question 15 on our grade 8 Gauss paper. The number of even integers between 1 and 103 is the same as the number of odd integers between 4 and what? 4 and what? So we got a bunch of even number possibilities. Alright. So how could we approach this question? Well, how many even numbers are between 1 and 103? In fact, how many even numbers are there between any sort of two odd numbers? Well, if we think about it, we start 1, and then we've got 2 as an even number, then 3. Then 4 is an even number, 5. 6 is an even number, and so on, all the way up to, say, 100 is an even number, 101 isn't, 102 is, and we stop at 103. Alright. So if we think about the numbers from 1 to 103, how many numbers are there in between 1 and 103? Well, if you do 103 minus 1, you're counting all the numbers from starting counting at 1, 2, 3, all the way up to 102. So there's going to be 102 numbers. But that would count 1 as well. So we actually have to subtract off another one. There's going to be 101 numbers in between 1 and 103. We start with an even number, and we end with an even number with 102. So there are going to be more evens, because we can always pair up even odd, even odd, even odd, even odd, and then we're left with an additional even. So almost half of the numbers are odd, almost half of them are even, but there are more even numbers than there are odd ones. So you just do 101 divided by 2, and that's 50.5. So round it up, and so there are 51 evens. Okay? This isn't the only way to show that there are 51 evens, but okay, what if we started at 4, and we want to count odd numbers? Well, you'd start with 5, 6, 7, 8, 9. 5's odd, 7's odd, 9's odd, and you keep going up to some point, some even number, let's call it 2n, because how do we know it's going to be even? Well, all the answers presented here are even, right? So how many numbers are there between 4 and my mystery number 2n? So how many numbers are in between them? Well, just like before, 103 minus 1, we start 2n minus 4, but then we have to minus another one. So this will be 2n minus 5. Okay. And just as before, we can pair up odd, even, odd, even, odd, even, and the number before 2n is going to be 2n minus 1. You just subtract 1 from it. So there's going to be an additional odd here, just like there was an additional even up here. But roughly half the numbers are going to be odd, half of them are going to be even. So if we divide by 2 and round up, we'll see there are going to be n minus 2 odd numbers in between 4 and our mystery number, whatever 2n is chosen to be. Okay? So, for example, if n was 3, you would have 4, 5, 6 is 2 times 3, and 3 minus 2 is 1, and there's just one odd here. Okay, but we don't need to know that. That's just checking the formula. So what do we need? I need n minus 2 to be equal to the same amount. So n's going to be 53, and if I double that, 2n, the number that we go up to, is going to be 106. Now, of course, this is not the only way to do the question. This is just sort of the first thing that popped into my mind. 106 is what? Is that E? It's at the end there. Okay. This is not the only way to do the question. You could, of course, use this sort of pairing idea that we had up here. And up here we start our count at 1 and are focused on evens. If we shift over by 3, we're looking at 4. And we start counting the number of odds. So so a slick way to do the question, if we don't want to use algebra, is we say something like, okay, 1, 2, 3, 4, 5, all the way up to, say, 103. And we'll color code. Okay, what do we care about? This time, when we're counting between 1 and 103, we care about the evens, right? All the way up to 102. And then if we were to shift over by 3, we'd start at 4, and then 5, 6, 7, 8, 9, And then we'd go all the way up to, say, well, add 3, you get 106 here. But look what happens. When we're counting between 4 and 106, we want the odds. And now the odds are in the exact same position as the evens were before. Okay? So it's this kind of nice shifting thing. It's not immediately obvious that that's a way to do the question, but it is still a very interesting way to do the question. That, okay, if we start at 1, the next number that we is one we want to count, and then after that, and after that. And so if we start at 4, and the next number that we want to count is after. If we want the same count of these blue numbers, and we start at 1 over here, and then we shift over by 3 to start at 4 for our sort of odd counting sequence, the endpoints should shift by the same amount. Okay? And I think that's a pretty quick way and a pretty cute way to do it. But of course, it's not the only way. You can do algebra. You can do lots of things. If you had a different way, other than sort of messing around with algebra and actually counting things out, or other than this sort of shifting trick, I would love to hear about it in the comments. But that's it for me. I will see you for more math, more of our grade 8 Gauss, in the next video.